Hello friends, in this video we are going to take a look at one or two problems which are based on sum and product rules and which are going to be simple problems but which will nevertheless use both of the principles. Consider the problem of creating three-digit numbers from digit set. The digit set is given 1, 2, 3, 4, 5. So basically we are going to use only these 5 digits and we are interested in how many 3-digit numbers can be formed given these 5 digits. So the question is, how many 3-digit numbers can be formed? So when you start going for the answer, let's draw 3 blocks. So now we know that we are interested in the 3-digit numbers. So whether they are decimal numbers, they are any other kind of numbers, basically there is something called, let's say decimal numbers only. So there is something called as a 10th place. And there is something, or that means a unit place, sorry. There is something called as a 10th place, which is the second last place. There is something called as a 100th place. So we have these places somehow. So by the way, we are not interested only in the decimal numbers, but we are using the nomenclature from the decimal numbers. So there is something called units place, 10th place, and the 100th place. So there are, when nothing else has been mentioned, there are 2 conditions that need to be solved under this. So the first condition is repetitions allowed. Why we are bothering about this? We'll come to this point. Let's say repetition not allowed. So there are 2 conditions that you need to tackle here in such kind of questions. And why we are interested in repetition allowed and repetition not allowed? Because all of we have, due to experience, we have seen numbers such as 555, which is a valid number, and we have seen another number also which is called 543, that means 543, which is also a valid number. Also a number called, let's say, 122, 122, that is also a valid number. That means a number could be repeated once, number could be repeated twice, because we have only 3 places, so number can be repeated at the max twice, and this is out of experience. So therefore we are going to talk about repetitions allowed and repetition not allowed. So let's look at the first condition called repetitions allowed. So the first condition, repetitions allowed. Again, draw the 3 blocks. There is something called as unit place, something called as a 10th place, something called as a 100th place. So when the repetition is allowed, let's start filling them from units placed to the 100th place. So let's start filling it in this direction, right to left. So that means we are filling the units place first. So how many choices are there for the units place? You know that any one of the 5 digits could come here. So there are really 5 choices. So now, independent of what you filled in the units place, how many choices are there for the 10th place? We know that repetitions is allowed. That means whatever you selected here could also be considered. That means whatever was selected at the unit place can also be considered for the 10th place. So there is no choice which is going to be dropped out. So let's say you selected 5 here. There is 5 is not going to be available for the 10th place. Nothing like this is going to happen because the repetition is allowed. So same 5 choices are available for us here also. Also, because the repetition is allowed, we have the same 5 choices here also. So it is HTU. All these places have 5 choices. Now how to do? Mix these 3 numbers. So nothing else has been mentioned. So what we have to assume, we really have to assume, is independence. So immediately when there is an independence among the unit place, 10th place and the 100th place, product rule must come to mind. Now because of the independence, you can assume simultaneity, because units place could be filled independently of the 10th place, 10th place could be filled independent of the 100th place, all of these places could be filled independent of each other. That means it doesn't really matter whether you filled this first, then you went to this, or you went to this. Otherwise you selected 10th place first or H or U didn't really matter. So product rule is applicable. So the answer is 5 into 5 into 5. So basically there are 125 such numbers which could be formed when there are 5 digits available, 1, 2, 3, 4, 5. So we are going to write down every analysis of this repetition allowed case here. So repetition allowed summary. Let's say units place. What was the choice set? The choice set, let's say for the unit place we write it as CU, was nothing but 1, 2, 3, 4, 5. Let's say 10th place. If you write down CT, which is the choice set for the 10th place, which was again 1, 2, 3, 4, 5. And if you write down the choice set for the 100th place, then CH would be again the same. That means the same choice set was available to you over and over again. This is what the repetition allowed summary. Now that was about the choice set. The next is assumption of independence. Why do we have to go for the assumption of independence? Because nothing else was mentioned. So here I am writing down everything explicitly so that you could actually see what are the things that go into the analysis of such kind of questions. Nothing else really was mentioned, so therefore you go for the assumption of independence. Third thing, independence implies product rule. So that was about the first question, which is about repetition allowed, the first part of that, repetition allowed case. Now let's go for the second case, repetition not allowed. So here we are going to go for repetition not allowed case. Let's again draw 3 blocks. Same thing, units place, 10th place and the 100th place. Let's try filling them left to right, right to left. So when you start filling right to left, we will also see how does it matter whether you start filling right to left, left to right, or in any other order. So how many choices are available for the first place? That means the unit place is 5. Now once you know that whatever you have selected at the unit place cannot be used now in the 10th place because the repetition is not allowed. So one choice is gone. You don't really know which choice is gone because it depends on what have you selected. But one choice is gone. You recognize that, so that means the number of choices is 4. Now you know that there is one more less choice because you are choosing to fill the 100th place, the last one. So there are 3 choices. So there are 3 numbers, 3, 4, 5 now. So how do you mix these 3 numbers? It seems that the choices that you have selected really matters to the other, but it doesn't really. So again here, assume independence is not true. You don't need to assume independence. There is an independence. So we will also do the detailed analysis of this, why there is an independence. So basically there is an independence, so it implies product rule. So the answer 3 into 4 into 5, which is nothing but 60. Thank you so much for watching this video. Stay tuned with Ekeeda and subscribe to the channel Ekeeda.